A board question in ray optics. Question is derive an expression for the area of water through which light from bulb can emerge. The bulb, assumed to be a point source, is placed at the bottom of a tank containing water to a depth h. Let us consider a container in which water is present to a depth h. Let the point source be O, from which light can travel up to a critical angle and reach the surface. So in 3 dimension, it forms a cone, and on top view, it will form a circular patch. The rays which are having angle of incidence greater than critical angle will undergo TIR. So for finding the area of the patch, we can consider that maximum angle of incidence to be equal to critical angle. Let the radius of the cone be r. We know mu equal to 1 by sin IC. Mu equal to 1 by sin IC. So cos square IC equal to 1 minus 1 by mu square. So cos IC is equal to root of 1 minus 1 by mu square. Tan IC is equal to sin IC by cos IC, that is equal to 1 by mu by root of mu square minus 1 by mu. So that is equal to 1 by root of mu square minus 1. Also tan IC is equal to R by H. Therefore, R is equal to H tan IC, that is equal to H by root of mu square minus 1. Therefore, area A equal to pi r square is equal to pi h square by mu square minus 1.